Okay. Is it on?
Yeah.
All right. So we're talking about thermal energy. Thermal energy. Okay, so here's a question for you. And we talked about this before. But we're just going to remind ourselves. So who has a stove that looks like this?
Oh, I do.
Okay, someone does. Who is that?
It's in my grass.
I'm a cat. Or
Gigi?
it's my cat. So.
So, okay. So stoves that look like this, you turn it on and what happens?
It turns red.
It turns red and it gets really hot.
The hot button turns on.
Okay. So we have a bunch of, the temperature increases for the stove, and then you use it to cook stuff.
Yeah, like potatoes.
Now here's
No,
here's another interesting question. When you so it turns red and it's kind of scary looking. You don't want to touch it. If you turn it off and wait for a couple minutes, what does it look like then?
It's just normal color.
Does it look red still?
No.
No, it gets back to a normal color. So it looks normal, but if you touched it, what would happen?
Burn your sarcophagus.
Yeah, well, it would burn whatever you touched it with, your hand or your elbow, whatever you touched it with. Okay? So this is a kind of confusing question. Like, what is happening? There's something happening with the physics of the stove that makes it really, really hot. And sometimes it looks red, sometimes it looks normal. But if it's hot, it's always going to burn you. It's always going to do something bad to you. Okay? So scientists for a long time were really confused about this, but eventually they figured out how it worked. Okay? So if you remember, these are some molecules in a substance. These little circles here I'm drawing. So this looks worse on an iPad than it does on a board usually.
Good job, Mr. Bagman.
Okay, so scientists discovered that what is happening to these molecules when they get hot? You remember?
They move real fast.
They move.
They shake, vibrate.
They vibrate. Yep, that's exactly right. So I'm not so good at drawing this, but if you can look, they all start shaking around, just kind of like this. And this shaking, this movement of the molecules, is called thermal energy. So it is movement of molecules that actually, you know what? So it's energy expressed in molecule vibration. So if a molecule is vibrating, it has thermal energy. All right. Another thing to note that in physics, thermal energy is one word for the vibration of the molecules. Another word is temperature. So thermal energy is the same thing as temperature. Okay? Now here's a question for you. If I increase the thermal energy, will the vibrations go up or down?
Up. Down.
We have some up and some down. The vibrations will go up, okay? So the hotter something is, the more the molecules are vibrating. Okay? Now if I decrease the thermal energy, what do you think is going to happen?
Down.
The vibrations will go down.
Down.
Increase the thermal energy.
No.
Vibrations go down. Now, I bet some of you are going to remember this part. If the vibrations go down as I'm decreasing the thermal energy, do you think I will ever be able to decrease the thermal energy enough until there's no vibrations at all?
Mm-hmm.
Yes. What's that called?
Absolute zero.
Absolute zero, okay? So absolute zero is when there is no more, or when a substance is so cold.
Wait, are you making a video?
Yes, we are. So cold that there are no more vibrations. Okay, now who wants to look up what temperature absolute zero is? Damien?
Isn't it 0 degrees?
It's not 0 degrees. So 0 degrees in Celsius is when water freezes, but it can get a lot colder than 0 degrees Celsius, because think about in Canada, sometimes it's like negative
Minus
30.
25.
Yeah, minus 25. So absolute zero can't actually get any colder than absolute zero because they can't vibrate any less than no vibrations, right? So Damien's looking up absolute zero. Tell us what it is in Celsius and Fahrenheit, okay?
Citlali Diaz, Rafael Diaz, and Ivan Garcia to the office, please. Citlali, Rafael, and Ivan, please come to the office.
Ow. Later.
Did you almost find it, or do you want me to look it up?
I just went on the post yet and it
It
didn't
didn't pop
show,
up?
so I think on Safari.
Okay.
It is 200 negative 273 Celsius.
Degrees Celsius, and what is it in degrees Fahrenheit?
459.
So is that cold?
Yes.
Yeah, that's as cold as anything can possibly get, because that's when there's no more vibration in the molecules. Okay. So, yes,
So
Missy.
it's basically like freezing an ice cube.
It's way colder than any ice on Earth. In fact, this temperature is so cold that scientists have never been able to make it on Earth, but they have been able to make it in space. Well, I think on the space station. I'm not sure though. Okay, so thermal energy is the vibration of the molecules, and that's what heat is. So when you feel that something's hot, you're feeling the vibration of the molecules. Okay. Any other questions about thermal energy? Okay. We're going to later, probably not before lunch because we don't have that much time, but later we're going to talk about how thermal energy applies to the states of matter. Do you all remember the states of matter? And how it can help change